to connect to the Wi-Fi, this is where I can custom that. Wireless channel, you see I have 11 channels that we talked about, the 2.4 here, the 11 channels that we had in there. They will change it to challenge accept. Yeah, exactly. So don't do that. Don't do that. It's not that easy. It's not that easy, but you can be tricked by many ways. See G mode, working in G mode or not, enable hidden wireless, so it will not broadcast my SSID. Security mode, I can choose many different kind of security, right? Disable wireless security, I will connect without password at all, right? The web, something that you can broke in 5 minutes maximum, right? WPA still a little bit weak. This is good, right? But still have vulnerabilities. Wireless and wireless security enhanced. Auto wireless WPA, no, should be a company here with a radius. Well, maybe this is what they mean. If it's the radius one, this is the best one, right? We're gonna talk about those. Here is the IP of my router, right? So if the IP of my router, I told you, even at home, if you're gonna try, I don't know in India what is the norms in there, but if you can try this address in your browser, you will connect to your router, right? If you didn't change the password there, just go and change it quickly, because basically they will give you one with admin or admin one, or it depends on the company. If your router belongs to a domain, so you put the domain name here. Enable DNS relay to DNS if you have a DNS server. Enable DHCP server, you see, and I'm giving a range of addresses from 100 to 199, for example. This is how we're going to distribute. So 192.168.0.100, this is the first computer, right, that connect to my Wi-Fi. The second will have 101, 102, 100 till 199. I can change that. I can go, for example, from 50 to 200, right? Having more computers, more devices inside that one spot. DHCP lease time. The same lease that we had on the server, I can put in minutes, some days or some hours or some whatever. Add DHCP reservation. You remember the reservation that we did on the server? I can reserve here even in my router. You see computer name, and I put the MAC address of that computer, and I will reserve for him, for example, the address 220, right? So I can play with those things, and you have the same mainly, even if you don't have a D-Link, you have mainly the same options in all the routers, right? So at home you can go and play. If it's not secured, it depends on the ESP. This is what I told you. OpenWRT is one of the best open source to the router. So you just upload it and you can have access to everything, even programming the interface here or whatever, because it's an open source. If you go to advanced, you see I have a very good firewall here. Virtual servers, I can schedule some traffic in a port number, TCP, UDP, application, blah blah blah, and the name of it, or this is the IP address, name and IP address of that communication, right? Can put private, public, whatever. Port forwarding, something that you're going to study also on the routing after, especially on the Linux part. Application roles, I can trigger something. This is the firewall. So all this is more about security here. I can block some MAC addresses, computers, that they will not be able to connect to my router or Wi-Fi. Website filter, I can filter websites so nobody can visit that website, for example, or never or always can get access or whatever, right? And here you go, firewall setting, those things. So we're gonna talk about them on the next chapter, the security and the encryption stuff. DMZ zone, I can choose and enable DMZ in my router inside. All right, demilitarized zone in some range of IP address computer. That all the firewall will not be applied to that IP specifically, right? Advanced array. This is about beacons and rate, the interval of beacons The range, you see, he's giving me some details. Each 100 milliseconds, the range is from 20 to 1000. Default 100. Fragmented or not? See the fragmentation here and preamble of it. Advanced network. Plug and play, enable the one ping response from outside, the IP address from outside, and so on. Tools. Here is where you can change your logon, right? So here you can type Hamza, and I will choose my password. For example, this is admin. This is a simple user. Simple user will not have all the permissions to do everything, but some basic stuff here. Remote management, I can put some IP address in the port number. I will open it in my router, so I will be able to reboot from outside. Status will give you all your configuration, the name, encryption disabled, blah blah blah, the SCP or mask, and so on. So you see basic stuff. Some stat here, packets that you transmitted, you save it. Wireless MAC addresses, working on. See, I have two network cards in this simulator, of course. Oh, this is the first MAC address, the second MAC address, and working in mode 2.4 gigahertz, 2.4 gigahertz. Of course, you have the second website there. You go here on TP-Link. You saw you can find many more complex and advanced routers. You see by categories here, right? Business, switch, smart management, standalone wireless app. I don't know what is this models here of the TP-Link, DSL gateway, cable modem. You can go to TP-Link cable modem and see TC whatever. Then you have configuration and see how things work inside, right? So you can play with it after when you have time. It's always good. To see this. The security of the Wi-Fi, of course, the telecommunication or even data transportation is not secured by default. So we always implement something called security on top of it, right? Because it's just bits transferred from something to something. This is the technology of moving things, data from one side to one side. So there's no security in this conception, on these concepts at all by default. So we need to implement security on top of it always. Like for example, the encryption of communication and the access point and this password that we saw, how to connect, whatever, blah, blah, blah. And for the Wi-Fi, it should be encrypted. It should be encrypted on what? We're going to talk about the encryption better on our next weekend and see what is really the encryption and how it works and what is the algorithm, what is the key, what is the how for what we use them and so on, right? So for now, we have the web wired equivalent privacy. This is one of the this is the first mainly encryption that we used for the security of the Wi-Fi. It's very weak. If you are working on still working at home on WEP or web, go and change it quickly, right? Because of you can find even your grandma neighbor, not even a hacker, she can crack this key. It's very easy, right? So nobody is working on those things. Well, trust me, I did find sometimes few years ago, couple years ago, I find neighbors working on web, still working on web. That was really weird, right? On 2018, 2019, people still working on web. This should be disappeared on 2013, 2014. It's done, right? It's really weak and a really easy crackable key. So the key is encrypted on 128 to 256 bits. Initially was on 64 bits for the key length. We're gonna know what is the key next weekend, right? We will not go to the encryption. It's a big part, big other chapter. But as you see that we can have different length key, but here when all the packets are communicating, they are using the same key. This is the weakness of the web. So the more we're going to scan and absorb those packets in the air, so we're going to sniff them, and after we can analyze and bring back the key, right? So break it or crack it back, because it was using in all communication the same key of encryption. We get an improvement on the WPA, of course, so which dynamically assign every transmission its own key. So this is the first main difference between this swap and the WPA, right? Here, all the communications use the same standard key. Here, we started getting things better, much better, right? We are using a key for each transmission, specific transmissions. We have different key. The encryption protocol used in WPA was replaced by a stronger encryption protocol for the updated version called WPA2. Now we're going to talk about it here, right? Now we have even WPA3 that since 1 year ago, something like that. All right, so this WPA was replaced by stronger, which can be enabled on most customer grade access points. WPA2 includes support for the previously released WPA. So they are WPA2 and WPA, they are backward compatible. The most secure Wi-Fi communication is made possible by combining this WPA2 or WPA with a radius server. Radius server. And not just radius server. Trust me, if you really want to have a stronger, a strong security, you need to use proxy servers and reverse proxy servers, and so go on and so go on, right? Between each node and each node. What is this radio service? So we're gonna have the WPA, right, or WPA2 or whatever, but we will enhance it with this is called WPA Enterprise because it's designed for enterprise to have more security. We're gonna have somewhere a server also, so we will have an encryption of WPA, and also we're gonna identify and verify the identity of the user. So you need to use his username and password to get access, right? So the access is from this Kerberos server usually, or Active Directory server, or whatever database server that we can build it for security. So it's kind of a double check. We have all the encryption stuff, we have all the algorithm of security here, data integrity, whatever things that we're going to study on next week. And you're going to have a radius over it. So this one is called WPA Enterprise or WPA2 Enterprise, using this separated server or separated concept. And of course, it's not just like that. You're going to hide those stuff, right? You're going to hide those stuff by proxy server here and here, proxy server, and in between a reverse proxy server. So even that someone who come from outside, he will be lost in here just to get some access here or here. So there's ways to make it really, really strong. Server with WPA or WPA2 now as WPA Enterprise or WPA2 Enterprise. Respectively, WPA is also based on RC4. This is an algorithm of encryption that it's called RC4. We have many now, especially we are using the IES. We have the DES, the triple DES, Bluefish algorithm. There is many algorithms in the wild for the encryption. One of the most strongest one made by U.S. Army at the time is the advanced encryption standard that we are using. Also, even in our payment card now online and those stuff, this is the encryption that we use usually. So RC4 was one of those algorithms that we used before. Cipher. It introduced several enhancements to encryption, namely used for a temporary key integrity protocol. So you see, this TK IP is the thing that gives us the ability to assign every transmission its own key. Right? Using this technology with this algorithm, this is why we are able to change the keys for each communication, each packet. So the protocol contains a set of functions to improve wireless LAN security. The key length is 256, or it can go less than that also, 128, something like that. It can go much more than that, right? 1024 or even 2048. Much longer, very longer and more complicated. So per packet K mixing, the generation of a unique key for each packet automatically automatic broadcast of update keys, a message integrity check, a large initiation vector. So the first key that is generated from nothing, because after the keys are generated from the data before, right? Each data is used to generate the next key, but we should start from something, so we need to generate a vector at first of keys. This is the initiation vector that is initialized at 48 bits. In this one, it was initialized at 24. We don't have initialization vector in CCMP here, or changing message authentication code protocol. We're using more advanced technology. So, and the mechanism to reduce blah blah WPA was designed to backward be compatible with the web, to encourage quick, easy options, network security, blah 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 blah. New standards, web-based devices, simple firmware update. Yeah, so when they release, usually it's just a firmware update that you will be able to use it after in your router. WPA2 is the successor of WPA3, is WPA1. Sorry. Standard was ratified as on triple E by 11I. You see, so the 11I here. This means WPA2. In 2004, like its predecessor, WPA2 also offer enterprise. So we have this radius server with all the encryption stuff. It can be much more secure. Although WPA2 still has vulnerabilities, it is considered as the most secure one, but it doesn't mean that it's secure 100%. The WPA2 replaced the RC4 and TICA IP with two other stronger concepts and algorithms for encryption. So this RC4 in WPA2 was replaced by IS, so Advanced Encryption Standard, and the TICA IP was being replaced by CCMP, so another advanced cipher block chaining messages. Right, not even anymore those keys we are using here, cipher blockchain in messages. It's the very similar to this concept of the cryptocurrency, this blockchain. We are using the blockchain encryption. Okay, respectively, also mean to be backward compatible with WPA2, support TKIP, fallback in device cannot support CCMP. Developed by US government to protect classified data, blah, blah, blah. It's talking about the algorithm of IS here, CCMP, protect data confidentially by allowing only authorized network user to receive data, and it use cipher blockchain in messages authentication code to ensure message integrity. So it's not just changing the key for each one, but we have data integrity of the messages, so it verifies the integrity of data. We're going to talk about the integrity of data on next week when we talk about the encryption. We have this VPN stuff that we're going to study on next weekend, and we're going to talk mainly about encryptions. So we're going to talk about all those weird words that you are hearing here. Okay, pairwise, master key, caching, pre-authentication. You have research to do, please. You have a search about WPA3. What is the advantages? So what is on extra? Now we have WPA3. What is more secure in WPA3? And some threats here. Searching details, those attack technique on wireless hotspot. So what is a war driving? What is the evil twin attack? WPA cracking, WPS attack, right? So please read about. This is really interesting things that you can find here. We're going to talk about them also on the next module. You have an exercise that you need to submit with the research here on next Saturday, 8:30. So all the tables, we will not read them all. I will just explain you the first one here, and after you keep following the same. So here he's giving you IP address, original mask, subnet mask. So this is the original one. This is how it was subnetted. He's asking you number of subnets bits. How many bits for subnets we have here? Number of subnets. How many subnets we can have? Number of hosts. bits. So the number of bits of the host. Number of hosts per subnet. How many hosts or how many valid addresses we can have in that subnet. Network ID of the first subnet. Right. First valid address, first subnet. Last valid address of the first subnet. And broadcast of the first subnet. So this is subnet 0. First subnet, this means subnet 0. Right? And same thing. Here he's giving us this. See, this one is a little bit complicated. There you go. This is the original mask. And this is the subnet mask. You see the difference that we have here? Right. This is a little bit weird subnetting. Doesn't really exist, but it's good for the math and the brain on practice. When we're going to correct it, you're going to see. Okay. So same thing, same questions. Here he's asking for the fourth subnet. So it's a subnet 3. Fourth subnet is subnet 3. And so go on and so go on. So you have 6, I guess, or 7 tables that you have to fill. And we're going to correct it together on next Saturday. We're going to correct all this together on next Saturday, right? And next Saturday, we will do another chapter about the encryption stuff and so on. So let's see what people are talking about. They will change it to okay. And after my neighbor's Wi-Fi name is Dash on pass. Wi-Fi news. What does it mean? What? Dash on a Papa Wi-Fi. I don't know. This is more sounding like Teletubbies name or Papa Lala Tinky Winky, something like that. I don't know. I don't know what you're talking about, Chief. Seriously. Right. On a pass Wi-Fi. No, I didn't get it. What do you mean by host bit? Host bit, the host bit. How many bits they remain? The remaining bits. How many bits remain for the host, right? How many bits remain for the host, Malhar? Just Quran. Sir, what about the result? Yeah, after the result are ready. I will share them right after the course. And of course, we're going to take on the third week, not next week, but the week after when we do the one technology. We're going to take that Sunday and we will do the retake just before the project, right? We will do the retake of module 4. I thought it is in French. On n'a pas. On n'a pas de Wi-Fi, nous. C'est ça? On n'a pas de Wi-Fi, nous? This is it? On n'a pas de